The next area of Coulomb's law that we are going to treat now is what? Is system of charge on a triangle. System of what? System of charge on triangle. So this is reverse to the arrangement of what? Of charge. This is what? Reverse to the what? This is reverse to the arrangement of charge on or the arrangement of what? Of charge to the vertex of triangle as shown below. So that is, if we have a what? A triangle in this form, so in this is triangle now. If I put what? Charge, let me say charge Q1 here, I said charge Q2 here, and charge what? Q3 here. Forget that the distance between Q1 and Q2, let me call it what? R1. Distance here is R2. Distance here is R3. So the arrangement of this charge Q1, Q2, Q3 on this triangle is what we call the system of charge on triangle. And here now, let us do this. Assume that, let me assume that what? Here we have let me say here we have a positive charge, here we have a positive charge, and here we have a negative charge. Positive charge here. Now positive charge here. And here we have a negative what? We have a negative charge here. If you are now asked that find the net charge or the net force on, let me take this, find the net force on this Q2. So if you are asked to find the net force on this Q2, what will you do? You will find the what? The force that exists between the what? The Q1 and Q2. And the force that exists between what? Q2 and the Q3. The force that what? This charge Q3 exerted on what? On Q2. The force which charge Q1 exerted on what? On the Q2. So by doing that, between the charge Q2, Q1 and Q2, are they going to attract all the power? They will what? They will attract. Because they will what? They will attract. Good. This what? They will attract. This Q2 will move towards A now. I mean the one we did in a linear system. So this Q2 what? Will move to this side. Instead of that, the force here will move like this to this side. This is what? The force. What is the force we have here? Is force what? 2, 1. The force that this charge Q1 exerted on what? On this. it will go like this. But look at what? Between this charge what? Q3 and what? And Q2. This is positive, this is positive. Instead of that, what happened? This, instead of what? Of this force to go like this, it will what? It will repel. So the force will what? Will come like this. So this is what? Force what? Force 2, 3. This is force what? 2, 3. Yes? For this kind of what? Of question, we are now asked to find the net force on this Q2. What we do next now? We need to what? To find the angle between these two what? Two lines. By finding the angle between what? These two what? Two lines. Let's call the angle what? Theta. But don't forget that this triangle, it may be equilateral triangle or isosceles what? Triangle. Any kind of triangle, the angle inside there will be what? Will be given. Assume that what? This triangle we have here now. Let us assume is a equilateral triangle. If it's equilateral triangle, all sides are what? Are equal. When all sides are equal, the all angle are equal. The all angle inside there will be 60, will be 60, will be what? Will be 60. So if all angle here are what? Are 60, Abi. So what will be the what? The angle we have outside here. The angle we have outside there, it will now be what? This angle we have outside there will be 120. Sum of angle on a straight line. Abi, by doing that, what will be the resultant force? The resultant force for this sketch now, you can withdraw this diagram outside. You will have it in this form. This is what? F21, and this is also what? F what? F23, and here is what we call what? The resultant what? The resultant force, the net force. So and this angle we have here is what? Is angle what? 120. By subtracting it, for this kind of this now, to know the resultant force, you will use what? Modify cosine rule using the net force. It will now be equal to the what? F21 square plus F23 square plus 2F21, that 2F3 cos theta everything square root. This is the formula that we use to find the what? The resultant force of triangle of a three charge in a triangle triangle. Now let's solve question on what? On this. But any question they give you on triangle, just apply this what? This format. You get your what? Your net force. So let's solve this question. A 3 charge plus 1 plus 2 microcoulomb and minus 3 minus 2 microcoulomb are placed at the vertex of an equilateral triangle of side 20 centimeter in vacuum. Vacuum, note it please. Determine the net charge on the what? On the plus 2. Yes, solution. Let me redraw the diagram. Let me draw the diagram. Let me say we have minus 1 microcoulomb. We have plus 2 microcoulomb. And the third one, we have what? Minus. We have minus 2. We have minus 2 micro what? Coulomb. So we are now asked to find the what? The charge on what? On the plus 2. So let me call this one what? Let me name it. We have Q1, Q2. This is what we call what? Q3. What is the distance between them? 20 centimeter, 20 centimeter, 20 centimeter. Good. So if you follow the what? The principle said that what? The first thing we need is what? Step. Find the individual forces. After that, we are asked to what? To obtain, to redraw the vector diagram. Now let me follow the what? The steps. The step 1 say obtain individual force. Yes, which one is our target charge here? Our target charge here is what? Is plus 2. This is plus 2 microcoulomb. This is our target charge. So we first of all find what? The force of what? Of 2 pound. This 3 of 3 exerted on 1. It will be Q1, Q3, Q1 over what? R square. By applying that, what will be the what? The K. 9 times 10 raised to the power what? 9. The Q3 here is what? Is 2 times 10 raised to the power minus 6. What is the Q1? Is 1 times 10 raised to the power what? Minus 6. By doing that, what is the what? Distance there is 0.02. Everything square. So if you press your calculator, you have F equal to what? 31. It will give you what? 0.45 Newton. 0.45 what? Newton. That is what? The first force between what? Q1 and Q what? Q3. The second one is what? We are going to consider the what? The Q3 and what? And Q2. So force of what? Q3 and Q2 will be K Q3 Q2 over what? R square. So what is the first 32? We have K 9 times 10 raised to the power 9 into what? Q3. Q3 will give us what? 2, which is 2 times 10 raised to the power what? Minus 6. What is the Q2? Q1 is 2 times 10 raised to the power what? Minus 6 to neglect the what? This. I mean, everything over what? Over 0.02 square. We now have what? T32 will be equal to what? 0.09 Newton. Yes, 4 times 9. Yes, it's given 36 divided by what? 0.4. This is what we have here. And the next thing will be what? We are finding the individual what? Force. Which is what? The force that exists between these two. Between what? These two. So the next thing is what? He said, you what? Step 2. Step 2 say what? Redraw the vector diagram. So to redraw the vector diagram here, we have something like this nature. This is what? My triangle. We have it in this form. This is what we call what? Minus 1 microcoulomb. This is my Q1. This is This is minus 2 microcoulomb. Here we have what? Plus 2 microcoulomb. Good. Yes, to know the vector diagram now. The problem we have now is this. Yeah, what is the force that exists here? It is repulsion or what? Attraction. You can see that what? This positive what will move down here because it's what? Force of attraction. This force we have here is F what? F31. Don't forget that what? This is what? Q what? This is charge Q1. This is charge Q2. This is what? Charge what? Q3. Good. So between these two charge, what do we have here? We have negative here too. Sorry, this is a mistake. This is not negative. It's plus. I'm sorry. This is plus. It's not negative. So it's not negative. Please be careful. You must be sensitive with what? With charge. So it's going like this. So if this one is positive and this one is also what? This is positive plus 2 microcoulomb. So plus what? 2 microcoulomb plus 2 microcoulomb. Yes, and we call it what? Charge what? Q what? Q3. So here is positive, here is positive. It will not come like this. It will what? It will go up like this. So this is the force what? Force 3 on 1. Force what? 3 on what? On 1. So between this positive and negative, what will happen to it? It will what? It will come down like this. Why come down? It will what? It will attract. But here it will repel. That's how you go like this. So this force will be what? The force of what? Of 3 into what? Into 2. Have you now? And don't forget that the angle we have inside here, the angle is equilateral triangle. The angle we have here is 60. The angle we have here is 60. We have here is 60. So to know the what? This angle now, this side angle, to know it now, it will be what? Angle 1 what? 120 degree. So if you draw the diagram now, you draw it, you have your vector diagram in this form. This is what? This, and this is this. We have F31. We have what? F31. The angle we have here is what? Is 120. So by this now, this is the vector diagram. After that, the next thing we do now is what? We are going to what? To obtain our resultant force. Step what? Step 3. Obtain net or resultant force. The resultant force is also called what? Net force. Please note. Here by using the formula. What is the formula for resultant force? We have what? The resultant force is net force. Net force is what? Force of what? F31 square plus F, oh gosh, 32 here. F32 square plus 2 into F31 F32 cos theta. Everything into the square root. This is we call modified cosine rule. If it's cosine rule, you put minus. So not minus, we use what? Plus is modified cosine what? Cosine rule. So what we now have now? The not will be what is the value for this one? Get is 0 point la 0.45 square plus 0.90 square plus 2 into the what? 0.45 times 0.9 cos 120. Everything what? Squared. The net force is supposed to be what? What is the 0 point what? Press the square of 0.45 to give us what? 0.205. Yes. Square of this is supposed to give us what? 0.90. Give us what? 0.81. Yes, that is 0.810 plus multiply this with what? Cos 120. 0.45 multiplied by 0.9. If you multiply 0.45 times 9, supposed to give us what? 0.8 0.8110 0.8100 cos 120. This cos 120 will give us 0.2 this. So F naught will be equal, add this together, 0.205 plus 0.810, it will be what? 0.6439. 0.6439. 0.6439 ought to be the square root. By finding the square root of this 0.239, it gives us what? 0.8029. The net force is 0.8439. No, I'm not mistakenly. 0.8439, 0.8029. So please point your calculator to confirm the answer. This will be the what? The net force for this triangle at charge plus 2. Let me solve 2 more questions on triangle before we now move to the what? Electric field intensity. So let us solve this example 2 on the system of charge on triangle. Solution. We are given what? The 3 charge. What? Charge plus 2 microcoulomb plus 3 microcoulomb plus 2 microcoulomb are placed at vertex of an isosceles triangle of base of side 50-50 and 60 centimeter. For the other triangle, 2 sides are equal. That is what? This side A is 50 centimeter. Here is also 50 centimeter. And the third side is what? 60 centimeter. If the base angles are this, the base angle are this, That is what? One angle here is -2 microcoulomb, the other one is 2 microcoulomb charge, where the third one is what? +3 microcoulomb. Determine the net force on plus what? +3. So this +3 is our target charge. So the first thing that we do according to this thing is to set what? Step what? Step 1, obtain individual force. So let us find the force between this and this. If we want to check it, we will have, let me call this one what? Q. I'm not going to put it to yes. Let me call this one what? Q1, Q2, Q3. So using what? F1, 2 to be K, Q1, Q2 over half square. By apply this, K is what? 9 times 10 raised to the power 19. What is Q1? Q1 is 3 times 10 raised to the power -6. Q2 is what? Is 2 times 10 raised to the power -6. Everything into what? What is the distance? 0.5 square. By solving it further, F12 is what? Give us what? 0.216 Newton. So it's the force between Q1 and Q2. The next thing is what? Let you find the force between Q1 and Q3. The force of Q1 and Q3 will be K Q1 Q3 over what? R square. K is 9 times 10 raised to the power 9 into what? What is this? 3 times 10 raised to the power -6. 2 times 10 raised to the power -6. You observe that what? 0.5 the same distance and the same charge. What do you expect? We have the same answer. F this equal to 0.21 Newton. That's the second. If you are doing that, the second thing is what? Step 2. The step 2 state that step what? Step 2 state that what? Redraw the vector diagram. So by redrawing the vector diagram, yeah, it's like we are the triangle in this form. Note that what? Mhm. In this form. Here we have -2 microcoulomb. We have +2 microcoulomb. This side is 3 microwatts +3 microcoulomb. This side. So to withdraw the diagram, you know that what? Between this and this, let me put this one here, +3 microcoulomb. Between this and this, which kind of charge do we have there? This repulsion or attraction? It's what? It's attraction. Therefore, the force will come like this, it will attract to go here. And if it's go here, it will be what? Force what? F1, 2. It will go like this. But for this charge here we have positive, here we have negative. So for this one, this is positive, this. The thing will what? Will go like this. Why? Because the positive, positive. The two of them are what? Are positive here. We have plus 3 microcoulomb. So when it's going up like this, what do we have? We have this. So if it's going up like this now, in between what? Q1 and Q3, we have F1 and F3. Good. So the next thing we need now is what? This angle. This angle is what? Is my angle theta. So by drawing the diagram, we have the vector diagram will be in this form. No, what was this angle what? Angle theta. But do you know one thing now? Yes, they said it's an isosceles triangle, but we don't know the what? The angle here. And for every isosceles triangle, the two bases are equal. So what will we do? But don't forget one thing here. Do you still remember that what the distance here is 5 centimeter, 50 centimeter, 50 centimeter? Here we have 60 what? Centimeter. You can use these three sides to find the angle here. If you know the angle here, let me call the angle here alpha. So we use to find this angle, we now find our what? Resultant force. If you look at the first question that I did before, we use this associated is a equilateral triangle. But this time around now is another triangle. These two angles are equal. If you can know this side, you know what this side with this. So let us find this what? This angle. To know this angle now, the best thing that we can do for ourselves is what? Let's say what? To find this angle, I can do another what? Using what? Cosine rule to find this what? This angle. Which is saying that what? A square equal to the what? B square plus C square minus 2AB cos alpha. This is it. So by applying this now, what are you going to have? What is my A? My A here is what? Is 60. My B is 50. My C is 50 minus 2, 50 times 50 cos alpha. This we are it. What is 60? Is 3. What is this to give us? 60 square. So this is what? 360. I mean, let me confirm it here. 60. Yes. 600. And what is 50 square? To give us what? 5,000. Sorry. The 50 square. Sorry. 50 multiplied by 50 to 5. Can you imagine? Is what? 250 plus another one 250 minus 2 into what? We have 2500 cos what? Alpha. If you add 2500 with 2500, I thought it should give us what? 5,000. Yes. 5,000. 5,000. So we have 3,600 plus this. We have 50 minus 2 times this 5,000 plus alpha. So you now have what? 5,000 plus alpha equal to the what? 3,600 minus 5 what? 1,000. By subtracting this, we have 5,000 plus alpha. Subtract this from this, we have 140. So we have 140. For the day, we have what? Cos alpha should be 140 over what? 5,000. Cancel each other here. At the end of the day, the answer we have is 0.28. If the have is 0.28, so don't forget that what? 0.28, we now have what? Alpha cos inverse of 0.28. By pressing alpha cos inverse, the final answer here by pressing second function, we have 3.74 degree. That will be the what? The alpha. So that is the angle we have here, it will be what? 7.3.4. So to know the what, if this 7.3.4 is this side, sum of angle on a straight line. So you now have what? To know the what, the actual angle there, it will be what? 180. Therefore 180 minus theta will be equal to what? 180 minus 73. Then you put 73 minus what? 7 what? 3.74. It will give me what? 106.2 degree. So therefore, sorry, minus alpha. So if would that be that? Uh, minus alpha. Therefore, you can now say what? The angle what? Theta. Therefore, the theta will be what? 106.2 degree. So we throw this now on a straight line. We need to what? To get the theta. Since we have know the value for theta, let me withdraw the what? The vectors. It will now be in this form. If you get it right, this form. The other one, the first one is what? F12. This side is what? F13. What is the angle we have inside there? The angle we have inside there, which is theta, is later what? 106.2 degree. This is the angle here. We now apply our general formula as usual, which we used to use. We say that what? The resultant force, or we say that what? The net force, so the what? Force 1 2 square plus force 1 3 square plus 2 force 1 2 force 1 3. Yes, now cos theta, everything square root. By applying this what? This formula, what is the what? The net force. The net force will be what? What is the final answer we get for the what? For the two force is what? Is 0.216 everything square plus what? 0.216 everything square. We have minus 2f 0.216 is 0.0 multiplied by 0.216 cos, what is cos theta? We're having what? 106.2. So everything what? Square root. This is what we have here. By doing that, we have f naught be equal to the what? 0.0467. If we square this, we also have 0.0467 minus 2. 2 multiplied by everything you have inside here. Mm, mm. Add this, square this. If square it and add it together to give you this, square this, multiply by this 2 to give you this, the same. What of cos what? One, what I call it, cos 106. By pressing the calculator, it will be mm, minus 0.2800. By calculator. By doing this, we have negative here. The F naught, it will end up with what? Is 0.0677, everything square here, everything square. You now end up with what? 0.2, 0.26 new what? Newton. That is what? The force. On what? On the net force on charge plus 3. But mind you, if you ask that what? If the 3 charges have been, they are placed them in the what? In the medium. In the what? Medium of relative permittivity of 1 point what? 1.5. Find the same question. And these 3 charges are placed in what? In the medium. Do you know that what? To know your force here, you will apply the relative permittivity of 1.5 here. So before the what? Continue. Others are the same, but the force will be what? Will be different. So that is all about what? The Coulomb's law in system of charges for linear, which is horizontal, and then for triangle. So the next thing is what? We are going to treat electric field intensity.